So, Chapter 1, Material. Most of you might have seen some of this before. So, it's still important. It's going to be how we classify matter and energy, as well as the difference between the interconversion of matter, so physical versus chemical changes. And so we initially have to look at let's define chemistry. That's a good place to start. So chemistry is the study of dynamics. It's a study of a before and a study of after, and trying to look at the changes that are happening in between. How is the reactant different than the product? What else has changed besides the reactant product? Is there more energy, less energy? Trying to define all of the components in our system is a lot of what we do in chemistry. So if we put this in words, it is the study of the composition, structure, and properties of matter and of energy consumed or given off when matter undergoes change. Okay, so we're going to be looking at the exchange, and we'll focus mainly on matter, but there is a relationship between matter and energy, but specifically we're going to look at matter first. And so we can look at matter. So we have two branches. One is a pure substance, and if a pure substance can either be made up. Well, let's actually, before we do that, a pure substance can be. Let's do an example of. We'll do this in blue. So pure substance might be NaCl solid or liquid water. Now, in both of these, I've shown molecules or compounds. We'll get into the difference or the similarity between those two words. But NaCl and H2O, so solid NaCl or liquid water, those are both pure substances. They can be combined to make a mixture. So we can define a mixture as two or more pure substances. So this is a mixture. Let's actually do something. Let's keep our uppercase mixture. So matter can either be a pure substance. More than one pure substance will make a mixture. Now those mixtures can either be the same throughout, homogeneous, or can have visibly different phases, or be heterogeneous. Okay. And so one thing that we can look at is one of the definitions of mixture and pure substance is that you can go between these two. So you can go from here to here by way of a physical process. So that is to say that we can separate using a physical process. Now, what is a physical process? So a physical process, so we'll just come down here and define that. A physical process is a process that changes, so change in the physical properties that do not change the chemical identity of the sample. So an example of that would be if I have H2O solid, so ice, going to H2O liquid, that'd be water. Now, in this process, we have changed the physical state of water from solid to liquid, but we have not changed the chemical identity. It is still water. And more importantly, this is a reversible process. And so I can go from ice to water, from water back to ice. And so that is unique to a physical process. So phase change is one of our most common examples of a physical process. Okay. So if we look at a pure substance, so I gave you two examples, NaCl. Oh, so let me, before I go too far with this, let's just finish this. So a heterogeneous mixture has, visible phases. So it is not the same throughout. Where a homogeneous mixture is also called a solution. So that's another name for a homogeneous mixture. And it is, we say that it's the same throughout. And a lot of the solutions that we can talk about and think about, we can think about a refrigerator. So a homogeneous solution is something that you can pull out of the fridge and just pour out. So for example, milk would be a good example of a homogeneous mixture. You do not need to shake your milk up before you pour it. Whereas orange juice, which especially if it has pulp, you need to shake up. So anything that you pull out of your fridge and need to shake up, that would be a heterogeneous solution where there's actually phases that you need to mix together and will actually settle back out into visible phases if left long enough alone. Okay, so a mixture, so NaCl, if I take NaCl solid and I put it with water, then I can make a mixture. So a homogeneous solution might be NaCl, or that would just say that I take solid NaCl and I dissolve it into water. So this is NaCl solid dissolved into liquid water. Okay, so that is combining two pure substances into a mixture. If we look at the pure substances, we have two pure substances. We can have a element that is the smallest unit of matter that maintains all of the chemical properties of. It can be basically the smallest unit of matter that maintains all the properties, chemical properties of that matter. There are smaller things that build up elements, such as like protons and electrons and neutrons. But the ratio of protons and electrons and neutrons makes an element what it is and gives it the properties that it does. So that's as small as we can go without changing the chemical nature of that element. So an element, if we have more than one element together, we can make a compound. Okay, so so if we combine more than one element, just like if we combine one or more pure substance, we're going to make a compound. And so the difference here, we'll do this in red, is that we can take a compound and separate it out into its elements only using a chemical process. So we can say separated, I'll put a D up here, separated. Using a chemical process. So when we make a compound, we are forming chemical bonds. The only way to break those bonds is a chemical process. And so let's define a chemical process right here. So this is a process where we see a change in the chemical properties that changes the chemical identity of the substance. Okay, so what that would example of that would be, so that would be is if I had a good example is, let's say, a hydrocarbon, like let's say methane gas plus O2, then that would form or would combust to form both CO2 gas and water vapor. Now, this is showing us right here that this is irreversible. So it can not go backwards. Okay, so that's important. Oh, we'll do this back here. Where were we? Here we go. The other thing I want to point out that something that we will see is that we call this either a molecule or a compound. Now, a compound is two or more elements chemically bonded together. Now, O2 is only considered a molecule. Now, there's not many things that are just molecules, not compounds. The reason why it's only a molecule, so it's not a compound, because it only has one element, not more than one. So this is, again, somewhat semantic in nature. I understand this. If you say, if you call every single thing that has more than one atom or element, or I guess one more atom, a molecule, you'll never be wrong. And if you call everything a compound, you'll be right most of the time. But there are a couple of situations where you have diatomic or triatomic molecules that only have one element, then technically they wouldn't be a compound. So there is a difference. Molecule can be anything. Compounds have to have two or more elements. So this would be a molecular compound. Really, it's just N2O2, these naturally occurring diatomic molecules that would only be considered a molecule and not a compound.